L'Hopital's rule is a method of finding limits. Remember back in the beginning of the section when we have an indeterminate form like 0 over 0 or infinity over infinity? This didn't tell us the limit did exist or did not exist. It's indeterminate, so we had to do some algebra to get it. L'Hopital's rule is going to be another tool that we can use to find limits like this. So without introducing L'Hopital's rule first, let's consider a problem that L'Hopital's rule could be used on. Here we want to evaluate the limit as x approaches 2 of the rational function x squared minus 4 over x minus 2. And as always, when we take limits, we first just try to directly substitute. But if I try to send x to 2 right away, I end up at 4 minus 4 over a 2 minus 2. That's a 0 over 0. That is that indeterminate form. And the limit is may or may not exist. In our second attempt, at this stage, we have one way to handle this. We can factor the numerator as x minus 2, x plus 2. Observe that it is a removable discontinuity. And now we can perform direct substitution on the function x plus 2, which is analytically the same as that, and recover 4. L'Hopital's rule effectively just states that I can take the limit of a quotient, f of x divided by g of x, when I get this indeterminate form by just differentiating the top and differentiating the bottom and looking at that ratio. So if I apply that to this problem, and I want to take the limit as x approaches 2 of the quotient x squared minus 4 over x minus 2, I first get that 0 over 0 form, but by L'Hopital's rule, I can differentiate the top as 2x and differentiate the bottom as 1, and now I can see if I can take the limit. And here I can just directly substitute. We get 2 times 2 or a 4, so we get the same thing.